surface area of sphere is basically 4 pi r square. So the surface area of circle, is pi r square, but it's a surface area of a three-dimensional object, which is 4 pi r square. The surface area of sphere is 4 pi r square, while if it is a hemisphere is half of the circle, the semicircle. So it's like here. Now remember that it's like eggshell, which is broken in halfway, then this is not solid. But if it is solid, like if it's like a solid metal ball and cut into two halves, what happens is that even this area is exposed. So this area is 2 pi r square and this area is pi r square. So in total, what happens is that total surface area becomes 3 pi r square. So this is something which you need to remember. The surface area of a sphere is 4 pi r square when it is as a whole. And surface area of a hemisphere, it is 3 pi r square, assuming that this is a solid sphere. So this is very important stuff. We got to remember it. And now coming to the cones, let's say when you talk about cone, it's one of the circular pyramid. So when you talk about cone, now cone has slant length L, or we can represent in small l, radius as r, and height as h. So the curved surface area, now here this surface is curved, this surface is curved, and this is the base. So the curved surface area is given by the formula pi times radius times slant length, pi rl. And of course, if I want to find out the total surface area, the total surface area will be inclusive of the base as well. So pi rl plus pi r squared. So pi rl plus pi r squared will be the surface area for the entire cone. So total surface area for the cone is pi rl plus pi r squared. So just giving an example of each of them. So let us say there is a metal bowl, assuming like it's a solid bowl, and its radius is 7. And I wanted to find out total surface area for this particular bowl. So the total surface area of a particular hemispherical bowl is 3 pi r square. Lots of times students make a mistake here. They write on 2 pi r square. So that's a complete blunder. 3 times pi times radius is 7 square. So it'll be 49 times 3 pi. So this is going to be 147 pi. And of course, you got to write down the units properly. You got to write down the exact value sometimes. Now, let us take an example for cone. So assume that there is a party hat and it's hollow. Okay, it's not like solid. So in that case, if I wanted to just find out the curved surface area, assume that this radius is 3 and this height is, let's say, 4. And I wanted to find out the curved surface area. So curved surface area will be, is going to be pi r l, which is going to be pi r times L. Now we don't know. So L we can find out using Pythagoras Theorem, which is 3 square plus 4 square, which is 5. So pi r times 5, which is pi times 3 times 5, which is 15 pi as the curved surface area. And if I wanted to find out, assume that this is a solid cone, with the proper base also filled up. So total surface area in that case will be pi rl plus pi r square. So pi rl is basically this we already got, which is curved surface area. So 15 pi plus pi times 3 square. So it'll be 15 pi plus 9 pi. So this is going to be 24 pi as the total surface area of this particular cone. So this is in general idea about cone and sphere. So here what we have is we have a cone on the top of hemisphere, assuming that it's this part is not exposed. This is completely below the cone. In order to find out the total surface area that is outside, which will be obviously this curved surface area. So first you need to see what areas that are exposed. So it'll be obviously pi r times L, that's this area, and then also this particular area, which is 2 pi r squared. Now remember here, this base is not exposed. That's why we're not adding a pi r squared to it. So it'll be pi times radius. Now radius we don't know, so you're going to apply Pythagoras theorem. So assume that this radius is r, which is also the radius of sphere, hemisphere. So it'll be radius square plus 12 square is 169. So radius square is going to be 169 minus 144, which is going to be 25. So radius is going to be root of 25. That's nothing but 5. So when you're finding out the curved surface area, so it'll be pi times 13. And also this area, which is 2 pi times radius square, which is 5 squared, which is 25 times 2, which is 50 pi. So let us say now we are going to do one particular question on total surface area of a pyramid. So assuming that it's I'll just first I'll draw a pyramid. So let us say if I have to find out the total surface area of a rectangular pyramid, or first I'll take a square pyramid. And let's say the sides of the base is, let's say 10 and 10, and these slant, this is, let's say this is 20. And I wanted to find out the total surface area that is for this pyramid. Obviously, like when you talk about total surface area, so you need to find out which are the surfaces that are exposed. So firstly, you can see that there's a base, which is very easy because you have this area of square formula, and then you have 4 triangles. So the important thing is, how do we get the area of these triangles? So if we can find out all the 4 areas, and if we add them, that will be the area or surface area of this entire pyramid. So first, let's put these names as A1, A2. A2 is one of the surfaces here. Of course, this has been 20. This is 20. So if I drop a perpendicular, now finding area of base is A1 is pretty easy because length 10 square basically. That's 100 centimeters square, if assuming the units are in centimeter. But now this is basically the sideways triangle we need to find out the area for. And if we can multiply that by 4, we'll get the entire area. Now remember that when you're finding out the triangle is this is going to be the height, which is like somewhere on the slanting edge. Okay, so that's not the height of the same as the height of the pyramid here. So in this case, what we will do is we'll first find out this height using Pythagoras theorem. So this length is 10 in total. So this will be divided as 5 and 5. So we'll apply Pythagoras to get this particular height first. So let's say this height is basically height square plus pi square equals to 20 square. And you get height square is 20 square minus 5 square. So this is going to be 400 minus 25, which is 375. And I'm not finding the exact value. So height is root of 375. Now, when you're finding out the area of each triangle, so area of each triangle is half, base is 10. So you can see the base of this triangle is 10, and the height of this triangle is root of 375. So if you have one face like this, there are 4 other faces as well. I mean, in total. So this you multiply by 4, and if I add 100 to this, so if I multiply this by 4 plus 100 will give me the total surface area of this pyramid. And remember that for pyramid, you don't have a straightforward formula. You need to visualize and then do the calculations. So this is about prism and pyramid. So just reiterating this particular question, that we have a brick basically, and from this brick a semicircular, or you can say semicircular cross section, or you can say half cylinder has been removed with a radius of 5, and we have to calculate the volume and total surface area of the left out part. Now, as we know that volume of any particular prism, now why I call prism is because you can see this cross section that is in green is throughout constant, and the height of the prism is 3. So area of cross section times height is the volume. Now, before I go ahead to calculate the volume, I'll need to calculate the area of cross section. So with the given dimension, the height, this is a square. You can see that this is 15. This is 15. So the area of the square is 15 times 15, length times width, minus pi times radius square upon 2. So I'm finding out the area of cross section by subtracting area of square minus area of the semicircle. So by that answer being 185.73. So take the radius as 5 because of this. So we got this answer. Now to get the volume, I can do, this is the area of cross section that we calculated to be 185.73 times height, which is 3. So volume of area times height will be the volume of the entire solid, which is going to be basically 185.73 times 3. So this is going to be the volume of the solid. You can calculate exactly. Now the second part that we have to do is the surface area, total surface area. Now actually, if you visualize, this is a complicated shape, but if you remember the formula, total surface area of any prism. Now this is like a prism because of the cross section area. It is perimeter of cross section times height plus 2 times cross section area. This is the total surface area of any prism. So perimeter of cross section times height, when we do, we'll get all of these. I'll get this, I'll get this, I'll get this, I will get this side areas, and I'll get also this curved area which is there. So that's the magic of this formula. So perimeter of cross section times height plus 2 cross section area, because these we're going to add up at the end, this and the other side of it. So now to calculate the perimeter, I'm just redrawing this here. So this is 15, this is 15, 15, this becomes 2.5, which is clearly evident because this is total is 15, this is 10. So 10 minus 15 minus 10 is 5. So this will be 2.5 and this will be 2.5. Now coming back to this part, which is semicircular arc. So what we do is 2 pi r divided by 2, that comes out to be radius, if I substitute as 5, that comes out to be 15.7. Now this, if I put in the formula, perimeter of cross section is 15 plus 15 plus 15, 15, 15, 15 plus 5. I'm doing so in order to get these two combined together, and plus 15.7 now. So the perimeter of cross section I calculated times height. So perimeter of cross section times height, that's this one. And once we got that, we add 2 times cross section area to it. So cross section area here we already calculated 185.73. So we calculate this part to be 65.73 times 3, 71 times 3, and plus 2 times cross section area, which ends up coming to 568.59. So that's how you calculate the surface area and volume of this particular shape.